Friends, my name is Dr. Jagdale. My principal subject is inorganic chemistry. Presently, I am head and associate professor of Department of Chemistry. This year means semester 3rd. I am going to teach inorganic chemistry, paper number CH 332. In inorganic chemistry paper, first topic is molecular orbital theory, short form is MOT. Introduction to molecular orbital theory. A molecule is formed by combination of atoms and energy is released. There is sharing of electrons from each atom and covalent bond is formed. There are two types of covalent bond formation. One is known as when two atoms combine, there is a formation of two center covalent bond. Example is formation of H2 molecule, formation of HF molecule, formation of HCl molecule, then formation of O2 molecule. Second is when more than two atoms combine, there is a formation of multi-center covalent bond. Example here B2S6 molecule, then Al2Cl6 molecule. All these are the examples of multi-center covalent bond formation. You know that when there is equal sharing of electron from both atoms or number of atoms, there is a formation of covalent bond. When covalent bond is formed, there are two theories for the formation of covalent bond on the basis of wave mechanics. On the basis of wave mechanics, there are two theories for the formation of covalent bond. Number one is called as valence bond theory. Short form is VBT, and second is called as molecular orbital theory. Short form is MOT. From molecular orbital theory, we get better interpretations for formation of covalent bond as compared to the valence bond theory VBT. Therefore, MOT is superior as compared to the VBT. Then, what is meant by valence bond theory VBT? According to the VBT, when there is a formation of covalent bond, that waves of various atomic orbitals combine and there is a formation of molecular orbitals, indirectly molecules are formed. You know that wave is energy. Suppose there is a formation of AB molecule. Here A combine with B and AB molecule is formed. Their wave is represented as psi AB, and there is psi A plus multiplied by psi B, or it is represented as psi A multiplied by here psi B. Means AB molecule is formed by the wave functions of atoms A and atom B. In other way, here psi is wave function of molecules formed from the atoms, and psi is equal to here n into C1, then psi 1 plus C2, here psi 2 up to the here Cn side, where psi is wave function, then capital N is normalization factor, and C1, C2 up to Cn are the various coefficients, and on that basis there is a combination of wave functions and molecules are formed according to the valence bond theory. Then what are the assumptions of VBT? Next point is assumptions of VBT. First assumption of valence bond theory is atoms combine and molecules are formed. Example is A combine with B and AB molecule is formed. Example, hydrogen atom element combine with chlorine atom element and there is a formation of HCl molecule. Then second assumption is actually there is overlapping of atomic orbitals. Atomic orbitals overlap, and then there is a formation of molecules, means molecular orbitals, and molecules are formed, and when molecules are formed they retain their identity. In VBT, when atoms combine and molecules are formed, they retain their identity. Then third assumption is the combination of atomic orbital take place on the basis of same energy. Means energy of various atomic orbitals. You know the atomic orbitals are s orbital, p orbital, d orbital, f orbital, etc. Same energy atomic orbitals combine or overlap and corresponding hybrid orbitals are formed. Means in valence bond theory, here first there is a formation of hybrid orbital, and when hybrid orbitals are formed, they contain unpaired electrons, and these hybrid orbitals overlaps with unpaired electrons of atomic orbital, and there is a formation of covalent bond. Then fourth assumption is that their symmetry is maintained. You know that s orbitals are spherical in shape and they are all over positive. P orbitals are dumbbell shape. D orbital first three are the lower leaf shape, and remainder two d orbitals means dx square minus y square and dz square orbital are what? Dumbbell shape and lie along the axis, and their symmetry is maintained. Means in symmetry 1s orbital effectively overlap with 1s orbital. 1s orbital and effective overlap is not occur with 1s with 2s or 1s orbital with 2p orbital. Means symmetry is maintained, and again their energies are considered. Then next one, here 6 point for assumption of valence bond theory is that once there is overlapping of atomic orbitals, electron density is concentrated in between the two nuclei of their atomic orbital. Example is, suppose there is overlapping of 1s orbital, and you know that this is 1s orbital. Then there is second 1s orbital, and when there is overlapping, that overlapping indicate that here this type of atomic orbitals are there, here positive, negative, and electron density, suppose 1 electron is present in 1s1, then electron density is in between them, and actually overlapping of that atomic orbital is represented as here this is 1s orbital, this is second 1s orbital, and 2 electrons are in between that nuclei, and their original identity is maintained or retained in the formation of molecules in valence bond theory. Okay, next one is molecular orbital theory, MOT. Short form is MOT. Here this theory was put forth by Mullikens, and according to this theory again, when molecules are formed, there is a combination of atoms. Means first assumption of molecular orbital theory is atoms combine and molecules are formed. Atoms combine and molecules are formed. Next point is assumptions of molecular orbital theory. First assumption is atoms combine and molecules are formed and they does not retain their identity. Their identity is not maintained when molecules are formed. Then second is again atomic orbitals come close to each other according to their size, then energy and symmetry, and then there is a formation of molecular orbitals. Then third one, whatever atomic orbitals are combined, that much molecular orbitals are formed. Suppose two atomic orbitals combine, then two molecular orbitals are formed. One is bonding molecular orbital and second is anti-bonding molecular orbital. When three atomic orbitals combine, three molecular orbitals are formed. One is called as bonding molecular orbital, second is anti-bonding molecular orbital, and third is non-bonding molecular orbital. Actually, in molecular orbital theory, wave mechanic principle is used and there is a collision between the atomic orbital nuclei and then new molecular orbitals are formed. When there is a combination of atomic orbitals, electron density is not concentrated in between the common region, but there is a delocalization of electron. There is delocalization of electrons in molecules. And like that, when there is a combination of atomic orbital, they obey the linear combination of atomic orbitals, LCAO. It is known as linear combination of atomic orbitals. Means when molecular orbitals are formed in molecules, there is a linear combination of atomic orbital, and these are the assumptions of molecular orbital theory. Then what are the comparison points between valence bond theory and molecular orbital theory? Here next point is comparison points between valence bond theory and molecular orbital theory. First point is atoms combine and molecules are formed and they retain their identity. What? Atoms combine and molecules are formed in vivity and they retain their identity. In this case, when atoms combine and molecules are formed, they does not retain their identity and new structure, size and shape is formed. Then second point for the valence bond theory is that once there is overlapping of atomic orbitals, same number of molecular orbitals are formed, and in that molecular orbitals, here electron density is concentrated in between common region. But in this case, electron density is not concentrated in between the two nuclei or common region. Here there is no delocalized electron, means electrons are not delocalized, but in third one means molecular orbital there is a delocalization of electrons. Here valence bond theory is a simple theory and it is just used for the qualitative methods, whereas molecular orbital theory is superior as compared to the valence bond theory, and it is also used for the quantitative analysis. Example for VBT formation: suppose atom A here combine with atom B, and these are the atomic orbitals. There is a formation of here molecular orbitals, and that common region is there, and they maintain their spherical shape. You know that 1s orbital is suppose this is second 1s orbital. S orbitals are all over positive and spherical in shape, their shapes are maintained, and what there is a formation of molecule. But in molecular orbital theory, when atomic orbitals combine, here complete A combine with B, that is A plus B, there is a formation of complete new shape, and here is a positive suppose electrons, and at middle one electrons are there, and there is a formation of bonding and anti-bonding molecular orbitals. And these are some comparison points between valence bond theory and molecular orbital theory. Then next one is, what are the atomic orbitals and what are molecular orbitals? You know that atomic orbitals are s orbital, then p orbital. There are 3 p orbitals, px, py, pz. Then d orbitals. There are 5 d orbitals, dxy, dxz, dyz, dx square minus y square and dz square. You know that molecular orbitals are represented as here atomic orbitals s, p, d, f, etc. Then here molecular orbitals are here sigma, pi, delta. These are the molecular orbital. Then if you consider the atomic orbitals, they have fixed shape. You know, s orbital is all over positive and spherical in shape. P orbitals are dumbbell shape. There are 3 p orbitals. Px lie along the x-axis, py lie along the y-axis, pz lie along the z-axis. Like that, suppose if you consider the d orbitals, there are 5 d orbitals, dxy, dxz, dyz, dx square minus y square and dz square. Out of that, first 3 lie in between the axis and they are lower lip shape, whereas remaining 2 d orbitals means dx square minus y square and dz, they are dz square, they are dumbbell shape and lie along their respective axis. But when molecular orbitals are formed, you know that this is sigma molecular orbital, pi molecular orbital, delta molecular orbitals. Here sigma bond, pi bond and delta bonds are formed there. Sigma overlap is along the axis and that is the maximum overlap, and you know that sigma bond is a strong bond as compared to the pi bond. Sigma is along the axis, overlapping is linear, whereas when pi bonding is occur, you know that pi bond formation perpendicular to the axis, and 2 lobes are there, one is above the axis and second is below the axis, and that's why pi bond is weaker bond. Here delta bonding molecular orbitals are in the what? When there is a d pi types overlap, or when d orbitals are overlap there. Then what are the comparison points between atomic orbitals and molecular orbitals? Here s, p, d, f are the atomic orbitals. Then sigma, pi, d are the molecular orbitals. They have fixed shape. S orbital spherical, all over positive. P orbitals dumbbell shape. First 3d orbitals lie in between the axis and lower ellipses. Remaining 2d orbitals means dx square minus y square and dz square are dumbbell shape. Then third point is here these s orbital means atomic orbital, p orbital, d they are the monocentric, but molecular orbitals are polycentric. The formation of this s, p, d, f in atom is not depend upon the any other factor. Here suppose if you consider hydrogen atom, there is 1s 1 electron means 1s orbital is there. If you consider nitrogen 7 atomic number 7, there is 1s2 2s2, then 2p3 means 1s orbital is there, 2s orbital is there, and 2p orbitals are there. Like that these atomic orbitals are independent, but molecular orbitals are dependent upon the what combination of atomic orbital. Their entity is depend upon the what type of combinations are occur, and these are some comparison points between the atomic orbitals and molecular orbitals. Next point is here linear combination of atomic orbitals. Next point is linear combination of atomic orbital, short form is LCAO. According to the molecular orbital theory MOT, when molecules are formed, there is a linear combination of atomic orbitals and then molecular orbitals are formed. Then how linear combination of molecular atomic orbital take place? Here suppose atom A combine with B and there is a formation of AB molecule. Then for AB molecule, wave function is represented as here psi AB is equal to here lambda into phi A here plus minus phi B. Here psi AB is wave function of AB molecule. Then lambda is wavelength, it is one of the coefficient. Then this is phi A for the wave function of atomic orbital A. Then phi B is wave function for atomic orbital B, and there is addition and subtraction, that is plus minus. Suppose homonuclear diatomic molecule is formed. Example is formation of H2 molecule. In H2 molecule, here psi, here H2 is equal to this lambda is equal to 1 because it is a homonuclear diatomic molecule, and into the bracket here psi, suppose first hydrogen atom is H1, then plus minus here phi, here second hydrogen atom is H2. Second hydrogen atom is H2. According to the linear combination of atomic orbital, electron density is occur on the basis of wave function, and that densities and probability of electron is determined by plotting various graphs. And suppose there is first addition of two wave functions. Here first one is this is for first hydrogen, here is a plus, and their atomic orbital wave function is represented as supposed to be the psi phi 1, and this is for the first hydrogen H1. Then for second hydrogen, this is represented like this, and here is second hydrogen again plus, and this is for the second hydrogen phi 2 and it is represented as H2. When these two wave functions are combined, means there is addition, then the large wave function is obtained. The large wave function is obtained and that wave function is represented as here is for first hydrogen, this is for second hydrogen, here is a plus and here is phi 1 plus phi 2. You know that phi 1 and phi 2 are the two wave functions for first hydrogen atom and here second hydrogen atom, and there is a combination and large curve means wave function is obtained. That graph indicate the probability of finding electron and when there is a combination, but when there is a subtraction means minus, at that time this is the wave function for first phi 1, that is first hydrogen, here is a plus, then for second hydrogen this is H2, this one is H1 and this is H2 and this is phi 2, and when subtraction is occur there, that wave function is represented as this is for first hydrogen H1, this is second hydrogen H2 and here is a plus and here is a minus, here is a plus and here is a minus, and that graph is out of that boundary line and there is a subtraction. That addition and subtraction is represented for homonuclear diatomic molecule. Here psi for H2 molecule is equal to here pi for first hydrogen plus this is first type of combination and here minus, this is a subtraction. Then that addition and subtraction is represented in two ways. Here suppose first one is addition, it is represented as psi g. Here g means geared, there is addition, there is addition, and when addition is occur, it is called as here phi 1 plus phi 2, and when subtraction is there, it is represented as psi u and that is equal to here phi 1 minus phi 2, and electron density is generally determined by squaring these values, means when squaring is occur, you take the square of this, that is phi 1 plus phi 2 square and here phi 1 minus phi 2 square, and you know that values are what? For probability determination and density of wave functions and electron is determined. Here there is a square of this first factor, means phi 1 plus phi 2 square, here below, here phi 1 plus phi 2 bracket square is equal to phi 1 square plus twice of phi 1 phi 2 plus phi 2 square, and in second one here phi 1 minus phi 2 bracket square is equal to phi 1 square minus twice of phi 1 then phi 2 plus phi 2 square, and when squaring is occur there, then there is a subtraction, that is a minus, and when addition or combination is there, here phi 1 plus phi 2 square is equal to phi 1 square plus twice of phi 1 multiply by phi 2 plus phi 2 square, and like that you can determine the wave functions and the probability of electrons, and there is a formation of molecular orbitals according to the linear combination of atomic orbitals. According to the linear combination of atomic orbitals, whatever be the atomic orbitals are combined, that much molecular orbitals are formed. In H2 homonuclear diatomic molecules, here two atomic orbitals combine and two molecular orbitals are formed. One is bonding molecular orbital and second is anti-bonding molecular orbital. Like that, in other molecules also, there is a formation of bonding, non-bonding, anti-bonding, etc. types of molecular orbitals, and these molecular orbitals are formed on the basis of wave mechanics, and that wave mechanics is linear combination of atomic orbitals. That is linear combination of atomic orbitals, and in linear combination of atomic orbitals, geared and ungeared, geared means even there is addition, and ungeared means there is a subtraction, that is phi 1 minus phi 2, and geared means phi 1 plus phi 2, etc. is occur there. That geared is generally bonding molecular orbital and it is represented as A, that is equal to A, and ungeared means anti-bonding molecular orbital, it is represented as what? A star, and like that when bonding and anti-bonding is occur there, they are represented as a geared, that is even, and ungeared means odd, and that is the linear combination of atomic orbitals. Thank you very much.